this demo, we're going to take a look at the support ticket system at Tailwinds Traders and how we can use automated machine learning to help their support ticket team. So Tailwinds Traders is a fictitious retail company, and their amazing development team have created this fantastic website as well as this native application. However, as we all know, with new technology, when more and more people use it, be that partners and customers, sometimes they might find some issues with inside the application or the website. In the case of Tailwinds Traders, they have a support ticket system. So customers and partners will submit support tickets whenever they find some kind of issue with the application that they need support with. Tailwinds Traders has an amazing support ticket team, and they triage these different tickets and make sure that they get solved as quickly as possible. But these support tickets keep flying in, and the support ticket team are starting to feel a little overwhelmed. They did tell us that most people walk away very happy with their problem being solved quickly. However, unfortunately, some of the customers do not have a great experience and find long wait times. And so Tailwinds Traders management team asked this question: how can we help the support team? That's how broad often data science questions can be. It's can we find something in the data that can support us? What is it that is happening? What are the trends? And so before we start any machine learning problem, I just want to caveat that you need to explore the data. You need to understand what's in the data, the different distributions, and anything that might point towards an indicator that might be useful to do some form of prediction on. In this case, we have already done that. And one of the things I wanted to show you very quickly is what the data actually looks like. So this is the data. We have support ticket IDs, and each support ticket has a row. We have different information from geography to rating to theme to where it's from to who you are to the date that's created. And you can see we've also done some data engineering here in order to be able to create columns that machine learning really likes, so often numeric or categorical columns. And so now I've got my data in order. One of the things that I wanted to see if we could do is actually predict this duration column. So as a support ticket lands in the support ticket team system, I want to be able to predict how many hours or days that this support ticket will take, depending on all its other variables. And we want to see if we can learn this from historical data. The idea of this is, if we can predict the duration, we might be able to be more flexible on busy periods, staffing hours, as well as start to look at things like maybe we could incorporate a chatbot that would help us with frequently asked questions so that our support ticket team can focus on the harder problems. So this is our first step. We're going to try and create a machine learning algorithm that can predict the duration of a support ticket. So what I'm going to do is I'm going to go to the Azure portal here, and inside Azure, the way you get started is you click on the portal menu, click create a resource, go to AI and machine learning and select machine learning. From here you can fill in some basic information about the workspace. Just to note, if you are wanting to use automated machine learning or the designer facilities inside the UI of Azure Machine Learning, when you go to Workspace Edition, make sure you click Enterprise. In the Basic Edition, you can use the Azure Machine Learning SDK, and that includes the Automated Machine Learning SDK, but this is code first. We're doing low code first, and the Enterprise version gives us that capability. I'm going to nip out of this and go to a setup I've already used. So here's my machine learning setup, and as you can see, there's not a great deal of information in here. I would probably say this is more for the management of the resources, just like you see with most things inside the Azure portal. However, as someone who's using the studio, I actually spend most of my time in the Azure Machine Learning Studio. If you click the Launch Now button, it opens in a new tab. and this is called the Microsoft Azure Machine Learning Studio. And in here we can do everything from using the SDK with notebooks to automated machine learning to drag and drop interfaces. We can manage datasets, experiments, models and endpoints, as well as managing any compute resources or data stores that we want to use. It really is an end-to-end environment. And so first things first, as you come in here, we need to work on the data. So if I click on Datasets, we already have our 2 datasets here, as well as being versioned, and we can see who created them and when they were last modified. But if you wanted to add a dataset, you can simply drop down this create a dataset. You can create it from a local file, or you can actually create something called a data store. And so when you go to data stores and you add a new data store, you can actually attach to a storage account that is already available. So now we have our datasets in place. I'm going to select the Automated Machine Learning tab under Author on the left. As you can see, I've done some automated machine learning runs prior to this, and we can see they take around 30 minutes-ish to run. Therefore, I'm going to create the experiment and then we'll review a previously run one. So if I click on Create a New Automated Machine Learning Experiment, it has some breadcrumbs of the different stages that we're going to go through to create this run. First things first, we're going to select our dataset. You could add the dataset from here if you've not already done it previously. However, we have our support ticket data just here. We can create a new experiment and give it a name. I think of an experiment as like a folder of keeping all the different experiments and runs you do inside one name. So I'd want to assign this Tailwinds Traders support ticket V2. I can select my target column. This is the column that you want to predict, and so in our case this is duration. And you can also select the training compute cluster. So this is underneath compute, you can use things called Azure Machine Learning Compute. And this is scalable compute. So I just tell it that I need either a certain type of development machine, so that's my CPU compute. You can also create GPU compute, but basically it's multiple nodes. And when an experiment is submitted to them, they scale up. And when they're actually idle, they automatically scale back down again. So you really do only pay for what you use. In this case, I'm going to use my CPU compute cluster and click Next. Next, we're going to define the type of task. Well, I want to predict the duration column. The duration column is a numeric value, and it stands for the amount of time that has passed or that it took to solve the support ticket. Therefore, we're trying to predict continuous numeric values. And so this is a regression problem. How much or how many? So I'm going to click on regression. You'll notice down here there's extra feature settings you can set up. So if we click on view additional configuration, you can select a primary metric. This is what it's going to try and optimize on. However, you do get all of the metrics also delivered back to you. For my regression problem, I'm going to choose normalize root mean squared error. There is a great page in the documentation that will allow you to go ahead and read about all these amazing metrics. There's also this ability to explain the best model. If you click on this, it shows automatically shows explainability on the best model that's created. Explaining a model is really, really useful for responsible machine learning. So the ability for you to understand what columns and features inside your dataset affect your model. And so I'm going to keep that as explained. Obviously, this will take a little bit of extra time. If you know that there's certain algorithms that you don't want to be using, maybe you've tried them already, maybe you know that they're actually going to be very, very heavy on compute and you don't have the space for that, or maybe they're really big models and you're trying to put them on small devices, you can choose to block certain algorithms so that the automated machine learning does not try them. We're going to leave that empty. You can select the training time in hours, so we could select don't run any more than 1 hour. That can be saying, hey, like this is how much I want to budget for compute in some senses. And also you can be very careful then about how long you want it to run, how many runs you want it to do, etc. The trade-off. There is always a trade-off between training and accuracy in most cases. If I drop down validation, it's going to automatically select the type, but if you have a specific validation type that you want to do, you can select it. And then concurrency, this is how many different models it will run in parallel to each other. And so we will keep it as its default and click save. On featureization settings, in here you can actually give it more information about the different feature types, as well as actually including or excluding things. So for example, you can say that, well, actually support ticket ID is a unique value. It's an ID. This is not useful for our machine learning algorithm. We might want to say that actually we don't want it to pick out a certain customer. And so actually the patterns in the data, we don't want it to include that. Date created and date completed, we've actually got the breakdown of these dates when we did our own featureization. We might want to keep that. This is a duplicate column. Don't add in any extra data then that's not needed, because it will process it every single time. Completed tutorial, we have also added a new featured column. So instead of saying completed tutorial yes, no, we actually have a 1 and a 0, and we have the same for rating. High, low, we've changed to 1 and 0. Any more duplicates that sit down here. We can see that duration is already not selected because that's our target column. And if we skip to the next page, something that we might want to keep in mind is that actually when we're going to use this model, we won't have the completed date, right? We want the support ticket to land in the system and then we predict. So we can't learn from anything that we're not going to have at the time. And click save and then click finish. This is going to go ahead, validate that we've done a setup correctly, and also create a new automated machine learning run. It will take us to this page where it can give us updates on the status. So currently it will be about to start. It will then go into preparing phase, and from there move into running, and then finally completed. Once it starts running, you can start clicking on these two different tabs. Data guardrails gives you information about the data pre-processing that the automated machine learning run does. And models will start to populate all the different models that the experiment has already run. And so what we'll do is we'll leave this one just here, and we'll go ahead and review an experiment I've already run. So here's one that I've already run called support ticket regression. We can see it's got the green tick as completed. It tells us how long it ran for, so it took 32 minutes. It told us which compute target, as well as the data set that it input and who created it, and that was me. On the left here, we can see it gives us our best model summary, so we can see the voting ensemble method made a really, really good impression with our new normalized root mean squared error at 0.29. It's not ideal, but we could start working from here on that. We can also view all of our other metrics to just double check that it's as expected for our algorithm, and these different metrics can give us a lot of information about what is going on with our machine learning algorithm. There is a great documentation page that will tell you all about each of these different metrics. We can see that it actually chose to put all of the data in for training data. For those out there who are deep into machine learning, you'll know that you need a training and a testing set. And so it's used some form of cross-validation here in order to break up that training data and test different parts of it. We can also see that this example actually has a deployed model, and we'll come to that very shortly. And then finally, you can see some of the run summary examples. I mentioned that you can go to data guardrails, and this tells you what automatic featureization was done. And so we can see how it dealt with the validation data, and you can view additional details. We can see that some missing features were detected and what action that it took. And we can also see that none of our features had high cardinality, and so it double checked that we didn't have that. Then we can go to models, and we can see all of the different types of models with all of the different types of scaling algorithms and normalization approaches that it ran. And it really does run many, many algorithms. We can see that each algorithm took from about 6 minutes to 1.5 minutes to run, and they're all now sorted by our primary metric. So we can see that the voting ensemble and the stack ensemble methods both did the best job, just behind the max abs scaler. So a certain type of scaler seems to work quite well here, with lots of different type of tree algorithms just at the top. Again, there's some great documentation that tells you a little bit about what all of these different things mean inside the Azure Machine Learning documentation. If I click on this model, we can dive even further, and we can see all of the different metrics that came with this specific model, as well as the ability from here to actually be able to deploy this model. But before that, we had an explanation. Explanations is going into a slightly different topic than that we're covering in automated machine learning. However, I highly recommend going and having a look at the meaning behind what this explanations is around interpretability. But as we can see, what it can do is tell you what features in your data set are most important. And actually, if that is an issue when you're building a model, for example, is that discriminating someone? Is that meaning that we're not able to, is it finding a bias within the data set? When we click on deploy, we can literally deploy our model right from this page. We can give our model a name. We can provide a description and choose a compute type. We offer Azure Kubernetes Service and Azure Container Instances. I'm going to choose container instances as this is a test. However, when we do recommend that you use Azure Kubernetes Service when looking at moving to production. You can enable authentication under keys that allows you to make sure that you're protecting your endpoint. So any kind of security that you do around containers anyway should also be done in this case. You can opt for this no-code deployment that we're doing here, or you can use your own entry scripts and dependencies if you already have that set up, and then you click deploy. It goes ahead and tells us that this deployment has now started. So I have already deployed this model previously, and so I'm going to go to my endpoints on the left here. Just stretch out this category here, and this Tailwind Traders support ticket system is one that I deployed earlier. When we go into here, this is now an Azure Container instance that's running in the cloud. It has our automated machine learning ensemble method deployed onto it so that we can now query it using an API, and I want to show you how you can consume it. So it's in a healthy state, which indicates that the endpoint is available. We can also see when this was created, as well as the REST endpoint that I can use as well, and a definition. So if I open this definition in a new tab, this is going to tell me how we can actually query the data. And so one thing I tend to do, because it comes with this very, very large JSON string, is I'll copy the JSON string, move it into something like Visual Studio Code. And then there's a really handy thing that if you do Alt-Shift-F, it will actually format our JSON data so we can read it a little bit better. And definitely take a look through all the detail here of exactly what your endpoint is doing. However, I'm going to skip down here to the actual schema so we can see that it's got all of the different data types here. But one of the really nice pieces is that it actually gives an example piece of data. And so one of the things I always test first is if I select this data just here and copy it, one of the things that I can do is inside something like Postman, which is a nice UI for calling REST APIs, I can actually create a post request here that will go to an endpoint. So what do I need? I need my machine learning REST endpoint. So I'll copy that and go back to Postman and post that in here. And as you can see, it's going to call a scoring method. Under headers, we can see we've got content type application JSON. And then under body, we can see that I can actually add in the different setups just here. I will show you, however, that the one that we can use as the sample does work. So let me just remove that and paste in this one instead. And if I click send, we can see that it was a status 200 and our result came back. So given the information given here, it predicts that it's around 3.5 days to actually complete this support ticket given the metrics. And as you can see, it just returns you in a JSON string as well. If you added on another one, for example, so you can see how you could start to populate this data very quickly as a batch data set. We could change this to, for example, to escalated. We could change this to something like security. We could say they've not completed the tutorial, the rating is low, and the month for this is actually in July. And if we click send, then we can see we now get 2 different metrics, and just given some of those changes, it says that that support ticket will be dealt with slightly quicker. And so what we've seen there is a full end-to-end of how to use automated machine learning. You use from the automated machine learning UI, you can create your run, you can choose your best model, you can interpret your best model, and then if it's correct for production, you can actually deploy it to an Azure container instance and query it using a REST API.